Today we're going to talk about combinations, but let's kind of go back and remember what you guys learned yesterday. Permutation. So when you list out all the ways that you can actually scoop ice cream on a cone, these are the ways that we can actually have them stack up those ice cream. So in this case, if you can count, this one has 6 ways that you can do this. Now if you use the method where you're actually using spaces, there's 3 spots for these ice creams. We know that the first one you have 3 choices, then 2, then 1. So mathematically you can also come out with the number 6. If you use the formula that was given to you yesterday, again we can write it as 3p3, where this first 3 represents how many spots you have for the ice cream cone, and the second one is, the first one is how many choices you have for the ice cream, and then the second one is how many spots you actually have. So if you use a formula, it would be 3 factorial divided by 3 minus 3 factorial, and remember 0 factorial is 1, so this also comes out to be 6. Now we do the same thing for combination. You still have the same choices, but this time you're putting it in a bowl. And in this case, since combination is where order doesn't matter, these are considered to be the same choices. So in this case, there's only one way to actually have a bowl of ice cream with these 3 flavors. So you can think of permutation as like a specific ordering, and in terms of how you actually count them. In combination, it's just a grouping. It doesn't really matter how you select them as long as you select a group of whatever you need. So here's an example. If you're selecting a 3-person math team to compete in a math contest, and you can select a group of 5, how many ways can you select the 3-person math team? So this indicates it doesn't matter what order they're selected as long as you have actually 3 people. So same idea as permutation. I know there's 3 spots for this team. There's 5 to select from, so the first one you have 5 choices, then 4, then 3, and again this represents the spots for the team, and the 5 and the 4 and the 3 is the number of students you have to select from. But because we don't want to count them after we select them, we can rearrange them any way we want to. The way we're doing the top part here is that we actually are accounting for every single situation as in permutation. So in combination, what we're doing is that we're actually going to divide out the number of ways that you can rearrange those spots once you selected those 3 candidates. And so in this case, you have 3 of those candidates, and then 2, and then 1. And so this represents the number of ways that you can actually rearrange once you've chosen the team. So if you go ahead and crunch the numbers, this comes out to be 10 ways. So there is a nifty formula for this as well. On your worksheet, make sure that says equal. So you could use a formula that's written up here, but just like permutation, you can also write it as a symbolic thing. So if you see the symbol NCR, again, this is the same thing as permutation. This is representing the number of choices that you have or available, and this is the number of spots that are available. You may also see the notation in this way, or you may see the notation this way. All 3 of them do represent combination. So it's really handy to have this notation because writing out the work can be pretty long. So if I go ahead and use the formula for 3A, in this case they have 10 books. 5 books are nonfiction, 5 books are nonfiction, and 5 are fiction. And the question is, if the order in which they read the books is not important, how many different sets of 4 books can they choose? So we can write this as 10C4, because there's 10 books to choose from, and they want to read 4 books. So again, if we go ahead and plug this into the formula, this is what it looks like. The top one is your n, so you have 10 factorial, times 10 minus 4, which is your n minus r factorial. And then you have the 4 factorial, which is your r factorial. So remember, factorial means that you're starting from that number and you're actually multiplying it all the way down to 1. So it would look something like this. And all said and done, this becomes, the answer is 210 ways. But again, we can use without the formula and set this up a little bit more simpler. So again, if you know that you have 4 books to choose from, we'll just write 4 spaces there. For the first choice, you have 10 to choose from, so it's 10, then 9, then 8, then 7. Again, once we have chosen our books, we want to make sure we take out all the ways you can rearrange these 4. So we're going to go ahead and divide this by 4 factorial because there's 4 books, and we don't want to duplicate the way that we rearrange those 4. So writing this out, it looks like this. And remember, 4 factorial is 4, 3, 2, 1. And you can see you still come out with the same answer, just a little bit shorter than plugging it into the formula. So the next one's a little tricky. They're asking you how many ways you can actually pick all nonfiction, so all 4 books, nonfiction, or all books that are fiction. So if we go ahead and deal with the situation where you pick 4 books and they're all nonfiction, we could write it as 5C4. Because again, there's 5 books to choose from for nonfiction, and you only want to pick 4 of those nonfiction. But you have to understand that it's a separate event if you decide to pick fiction. So you want to then add, in this case, the number of ways of how to pick sorry about that, the first one's fiction, how to pick the nonfiction books. And again, there's 5 nonfiction books, and there's 4 that you want to choose. So if you go ahead and plug it into the formula, which I'm not going to write out, but it does come out to be 5 plus 5, that means that in this case there are 10 ways. So again, the other way of doing this is knowing that there's 5 books to choose from for 4 spaces. You can just write 4 spaces, 5, 4, 3, 2. And then we want to divide out those ways you can rearrange those 4 books once you have it. So we're going to divide it by 4 factorial. Because it's identical in terms of the numbers, I'm just going to multiply this by 2. And then you find out it's 5 times 2, which is 10 ways. Again, just another way to approach the problem without having to memorize the formula. So here's another example. You have 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. And the question is, how many different committees of exactly 2 seniors and 2 juniors can be chosen? So you have to keep in mind that you need basically altogether 4 kids to actually make this particular committee. So this is based on that fundamental counting principle where we're just going to multiply the number of ways that this can happen. So in terms of the seniors, again, we have 6 seniors to choose from. So we're going to write this as 6 seniors to choose from, and then we also have 5 juniors to choose from. So we have 6 seniors for 2 spots, and we have 5 juniors for 2 spots. And again, we're going to multiply this because, again, that completes your committee. This is actually one event altogether. So again, I'm just going to use the underline method here. So we have 2 spots. So you have 6 and then 5, and then divided by how you rearrange those 2 spots. Again, we have 2 spots for the juniors, so 5 times 4 divided by 2 factorial, because we want to take out the duplicates of arranging those 2 spots. And this comes out to be 15 times 10, or 150 ways. Now when it comes to the second one, the key thing here is at most. So that means you can have a committee with at most 4 students, or you can have 3, or you can have 2, or you can have 1. So in this case, you have to understand that, again, we want at most 4 kids, and then that's it. That would be a committee. But then we have another event where you want at most 3, and at most 2, and at most 1. So in this case, because they're all separate events, we want to add these number of ways that you can have these committees. And again, from here, it's just knowing that this is combination. So again, to have at most 4 students, doesn't matter which one they are, just adding up the top here, it looks like there are 18 kids. So 18C4 would be the committee of at most 4. That means that you would actually have 4 kids there. The next one would be a committee of 3. The next one, committee of 2. And the next one is committee of 1. So again, if you plug into the formula or crunch the numbers, you get 4,047 ways. Actually, it might be confusing if I wrote the at most, so maybe committee of 4, 3, 2, 1. That might be more easier to understand. Okay, for this one, you're going to toss 10 different coins. How many ways will you at least get 4 heads? So again, there's this word here, at least. So that tells you that you're going to have to add different kinds of situations. So if you want at least 4, that means that you're going to count the ways you can get 4 heads, then 5 heads, 6, 7, 8, 9, and 10, and so on. And because these are all different ways of counting each event, we're going to go ahead and add these results. So the first one here is going to be, let's see, 10C4, because again, we want, we're going to toss 10 different coins, but we want 4 heads to show. So that's one way we can have this. The next one is 10C5, 10C6, 10C7, 10C8, 10C9, 10C10. And that would actually show at least 4 coins where the heads are showing. So the following is just, again, you could use a formula, plug it in. If you did it the other way, this is basically what it would look like. For the first one, you have 4 spots, 10 coins to start off with. But again, you want to divide it by 4 factorial, because once you select those 4 coins, you want to take out the number of ways you can rearrange those coins. And it's the same for all the other ones. So for the second one, we have 5 spots, start with 10. And then we divide it by 5 factorial, because again, you have 5 coins to rearrange from there. The next one, 10 all the way down to 5, divided by 6 factorial, and so on and so on and so on. So if you did this correctly, let's see if we can get the scrolling over here. Let's see. The final answer for this guy will be 848. So see if you can practice getting the correct answer there. And the homework tonight will be your worksheet.